Hello everyone, I'm Claire. Today let's solve a problem. Well, this problem is, first we have a quadratic function over here. Then this quadratic function, it is negative x squared minus 2x plus 3. Now, we have 2 points from this function. It is, quadratic function is negative 3, 0, and 3 and 0, 3. And this point is B. This point is A. And if we have these 2 points, and the question is, if we line them together, of course, there's something I forget to tell you, that so here we have a point P. Now this point is a dynamic point, or we can say a moving point. If we have this point, then the point can move on this part of the curve, and we're going to find the greatest area of triangle PAB. Okay, we're going to find this triangle, find the greatest area of this triangle PAB. We're going to find the max value of it. This is our problem. Now, we have 2 methods. So the first method, we can use the distance from the line and the point. You know, what's that I have talked about in my video before. Now, using this formula, what we do, we actually add. Now, if we can how do we calculate a triangle? Maybe this triangle now looks like this, and remember this is x-axis. Now we can draw a line over here, right? A straight line over here, and this is 90 degrees. So we can use this high times this one. So then of course we need a times, and there's 1 over 2, right? So then that is the area. Now, how do we find out this high? Of course, now we can use that formula, right? Because BA, this length never change. So we only need to find out the greatest high. Okay. Now, if we need to find out the greatest high, like these. Now this is the distance formula. So first write out it. If we use the distance formula, so what's this linear equation? So it is actually x plus 3. Well, that's y equals x plus 3. Then we need to write it as ax plus by plus c equals 0. Now over here, we can move y to here, right? So that's x plus negative y plus 3. Now that's equal to 0. Okay, now a equal to 1, b equal to negative 1, c equal to 3. Good. Now what are we going to do next? If we have this, now we're going to plug it in. Okay. Now here it is equal to, right here it is. Don't remember, we have an absolute value. So here it is x. So actually in that formula, we can call it as a distance formula. But in that formula, it is a point that is already defined the coordinate of it. Already defined the coordinate of it. It can't move anymore. It's not a moving point. So we can write it as x0, but here's not, and there's x0 next and y0, and this is actually coordinate of p, but p can move. Then we can change y to some relationship with x. Now here it is x plus. Now here it is negative. Actually, it's a minus this whole part. Now that's plus x squared plus 2x minus 3. Now that's then a plus another 3, an absolute value. So over here it's square root a squared b squared, a squared plus b squared. So a squared is 1 and b squared is also 1, so it's square root 2. Good. Now what's over here? Okay, let's think. What's over here? Now, square root 2. Now here it's absolute value. I can put these two guys together, and this is the first thing, so it's x squared. Sorry, x to the 2, okay? Then plus x to the 2 plus three x absolute value, because this is being canceled out. So the function over here, it looks like you can try to draw it out. Actually, it's some point over here. Then it looks like this. So the largest point is over here. Now, here's 0. No, actually, this point is -3. Now, let's write it out. So we can change it to x plus 3 over 2. Now, whole thing squared, then we're going to minus 9 over 4, right? Good. Now, if we have this, then x plus 3 over 2 is equal to positive negative 3 over 2. Because now we let this whole thing go to 0, then we can move here and both sides square root 2, sorry, both sides square root it. Then over here we have this and this positive negative, and that means x is equal to -3, x is equal to 0. So over here, this is -3 and this is 0, of course. Then actually here, the problem is -3 and 0, of course. Then if it's like this, then what do you know? Then what do you think? Well, it's absolute value, so we're going to think about these values over here. And every value turns to positive. And I change and flap it over here. It's over here. Good. Now, we're going to find this. This is the greatest value, right? So, for this function, it's the lowest value. Good. No, that's actually telling us we only find this value. Then we just derivative it. Okay, we're 0. So, it's 2x plus 3. And let's go to 0. Then x is equal to -3 over 2. Good, -3 over 2. Okay, so the point over here, right? Okay. Hey, just this point, huh? Seems like this. Yeah, okay. Now, it's just this point, a little bit there. Okay, now, so it seems over here. Good, so, actually, if we can find out this, actually problem is actually solved. But don't forget, you only just find out the x value of it, then plug it back inside here. Now this whole thing just like, maybe this is the answer. It just looks like, it would just say this is the answer, so it's just the same. Okay? Then how do we calculate out it? Just calculate out it, right? And when we just plug it back inside, then that's 9 over 4 plus minus, not plus, minus over here it is 3 times this, so it's 9 over 2. That's equal to 9 over 2, right? Then if it's a negative number 2, so don't forget the absolute value. So it's 9 over, here's 9 over 4. So it's 9 over 4 because we have absolute value. And the whole thing over square root 2. Now, don't forget, we have another, we're going to times this guy. So this guy is, you can use the Pythagorean theorem. So it's Pythagoras theorem. Here it's 3 squared plus 3 squared, and whole thing square root. Square root 3 squared plus 3 squared. Now that is square root 18. 18, good. Now square root 18, actually it is 3 times square root 2. 3 times square root 2. Good. Now here it is, then that is square root 2, and over here is 9 over 4. And the whole thing over square root 2. Then this is going to be times, we're going to times 3 times square root 2. Don't forget a 1 over 2. Then that's what? Then that's equal to, you see, square root 2 and square root 2 has been cancelled out. So if we times 2 over here, it's 8. Now over 8, and we're going to times here, so it's 27 over 8. Good. Now this is the first method. This is the first method. Now, what's the second method? Now, the second method is a bit different. Because, imagine, you're going to have a triangle like this. Now, and this is the x-axis. Now, what we do is, here at this point, we just draw a vertical line. Draw a vertical line. And this part is K. This part is K. Good. This part is K, and where is the high? So we can break it into two triangles, and this triangle and this triangle. So the high over here, one of it, it's over here, and another one. Now we can set this one as B and this one's A. Then we can move it over here. Then that's this one. Then this is B plus A. Then the whole area is 1 over 2 KA plus 1 over 2 KB. So that's 1 over 2 KB plus A. Now, B plus A never changes. It's always like this. So the point is we're going to think about the K. Now, we're going to think about the K. We have this curve and this line, straight line. So we're going to think about it. Where is the point that their difference are the greatest? So if we use algebra, of course. What's that? So, what's now? Of course, if we use the algebra, so we use this function or minus this function now, then we just calculate out the greatest value. Of course, that's alright, but we have another method. What method? it's not actually a method because we can just guess and select it, but it's actually right. But if we're really gonna prove it, we must use the way that I told you. Just put some bananas and just like this. Now, okay, no, we can imagine that actually this point is when their slope are the same, so actually it's over here by y, you see? Okay, so the start point over here now. Okay. Now, because the quadratic function's increment is getting bigger and bigger, so their difference are getting bigger and bigger. But after the slope are getting their same, then the quadratic function its slope is getting smaller. Then the difference is getting smaller. Okay, that's why. Okay, right? So it's a point when their slope are the same, but we're gonna calculate it out. So we're gonna calculate it out. As I said, we use this function minus this quadratic function. Good. Okay. Now this quadratic function minus this linear equation. So this linear equation is x minus 3. So use this minus this. Good. Now that's negative x squared minus 3x. Now just derivative it, and that's negative 2x minus 3. Then that's equal to 0. So x is equal to negative 3 over 2. So x is at this point, at the half point. Okay, now if we can calculate out this, then we can plug it inside this function now. And that's negative 9 over 4. Negative 9 over 4. Now this one is minus, then actually it's plus. Now, this is equal to 9 over 4. Positive 9 over 4. Now, if we have this, then what does this mean? This means the height over here. It shows over here. Okay. Now, we can let this side times this one. And then 1 over 2. Okay, what's this? So, of course, this is 3. Then 1 over 2, of course, that's 27 over 8. Okay, so the third part, you see, don't you find any problems when we're calculating with their slope are the same over here? Oh, what did you find out? This value is a half of this. This is always a half. Is the middle point from b to 0. What happened? Right? What happened? Why is it? Now, y is the middle point from b to a. So it satisfies all time when it is a quadratic function when it's a quadratic function and a linear equation. So first we're gonna set these guys. One of them is y equal to ax squared plus bx plus c, and another one is y equals kx plus you can write it as t. Okay, now now if we have this, then first their interception points are one is x, one y1, and another one is x2, y2. Now good. Now these 2 points, because is there when there is where their interception. That means it's when we use this function to minus this function. the 2 0 point. The 2 points when y equal to 0. So if you minus them together, it is of course, so we're gonna find the 0 point. So we just let this way the guy minus this guy now, then equal to 0. Yes, then equal to 0. Good. Now then that's it. Here's ax squared. Sorry, I forgot to tell you. Using the Vieta's theorem, so we have that if we have two roots x1 and x2, so if we put them together, then that's equal to should be negative b over a. Then x1 times x2, that's equal to c over a. C over an a. Now over here, it's not E, okay? It's C. Now, here it is. Then that's plus B minus K times X plus C minus T. Now using over here, now B is this guy and C is this guy. Okay, A is A. Now here it is, x1 plus x2 equals K minus B over A. Now, and another one is x1, x2. It is equal to C minus T over A. Good. Now, actually, we only need to use this one, but we'll just write it out, both of them. Now, okay, so why dxd over dx? This is, now, about this one, we need to let their slope, we're going to calculate when their slope are the same, so 2a, what? X plus B, and that's the derivative of this part, this function. And what about this? Equals K. Good. Now, if it's like this, what's the next step? Now, what we have? X is equal to what? We can move B here and divide it here. Now we have B minus K. Sorry. It is K minus B. And the whole thing over 2A. Then that's equal to, now K minus B over A, it is x1 plus x2, then over 2, right? Here's 2. So x1 plus x2 equals, divide 2. So this is the middle point of x1 and x2. Or we're going to say the mean number of these two guys. This is this part. So, we know the answer here. It is 27 over A, right? Okay, so we solved the problem. Okay, let's write out the answer. Okay, so this is how we solve this problem. Okay.